Good day, stat students. So today we're going to talk about chapter 4. So there's 3 sections, 4.1, 4.2, 4.4, and I'm just going to put them all together here in this one. So we need to somehow gather up our data. And so there's different ways of gathering data. And we can either conduct a study, and a study can either be that we can run an experiment, or we can do an observational study. And then 2, we can just go ahead and take a sample. And some say that would be a sample survey, but we're taking a sample, okay? And so let's focus in on experiments, all right? These are really important for a researcher, all right? They tell us the most about variables, all right? So let me give you an example here. So before I read this actual experiment, I think about 2 years ago, so back in, say, 2018, I started seeing commercials about Bayer aspirin. The makers of Bayer aspirin went ahead and made a commercial, and they said, if you take a low dosage of aspirin daily, it could potentially prevent a heart attack. So that's some pretty bold stuff, all right, saying, hey, if we do this, this could happen, all right? And so why can the makers of Bayer aspirin make such a commercial, put it on TV, and everybody's okay with it? Well, because an experiment was run, all right? So the first experiment with regards to aspirin and heart attacks was back in 1980. So back in 1980, over 22,000 physicians participated in experiments. So the physicians were actually the subjects. Participated in an experiment regarding whether taking a low dosage of aspirin a day lowered the chances of getting a heart attack. And so the response variable here is getting a heart attack. So did the particular person, did the particular physician get a heart attack or not within a certain time frame? Yes, no, all right? Then the explanatory variable is, well, did they take an aspirin or not? And actually, in this study, they took a placebo. The other group took a placebo. So did they take an aspirin or did they take the placebo? So the placebo is usually just a sugar pill that should have no physiological effects on you, other than the possible effects that your brain does because it thinks it's getting some sort of drug. Okay, so I'm sure you've heard the placebo effect. All right. So the treatments here is that either did they get in the aspirin or placebo? Okay, so those are the different levels of the explanatory variable. All right, so those are the treatments. All right, and this was randomly done. And what I mean by randomly done is that as the physicians came in and said, okay, I'll participate in the study, they were randomly assigned to either get the aspirin or the placebo. That was all randomly done. All right, and that's an important aspect of every experiment. All right, and we're going to talk more about that in detail. All right, so what turned out is that 44% fewer heart attacks happened in the aspirin group versus the placebo group. Okay, and because of this, and because an experiment was run, now you know how like in the last section I said you cannot. Just because there's a high correlation between these two variables that you cannot say X causes Y. Well, here you can. In an experiment, you can, if you run the experiment correctly, you can say now that these two things are related. One is causing the other one. Okay, so if you take a low dosage of aspirin daily, your chance of getting a heart attack decreases. All right, and so let's expand on this a little bit. All right, so why is this an experiment? What did it show? So on and so forth. All right, so let's expand upon it. Okay, so what made this an experiment? When the physicians were assigned to a group, they were randomly assigned to receive one of the treatments. All right, they were randomly assigned. That's what makes an experiment is randomization. All right. Now, you might get into, say, a psychology course, and they're going to say something like this where, well, you need it's called a control group. The control group in this situation would be the placebo group, and that would be incorrect. all right? Because there are some science experiments that, because there's no subjects, there's no control group, okay? You may run an experiment that has different temperatures, okay? And so there's no control group in there. So what makes an experiment an experiment? The subjects did not choose for themselves which group they were going to be in. They were randomly assigned to be in those groups, okay? In this case, they were either randomly assigned to get the aspirin or they were randomly assigned to get the placebo. That's what makes an experiment, all right? It's that randomization. So why were the researchers trying to achieve, what were the researchers trying to achieve by the randomization? What happened when we did the randomization? All right, so this is an important key. Please pay close attention to this, all right? So we had the 22,000 physicians, and if, let's say, just for an example, just to give you some numbers, okay, because a lot of times just giving you some simple numbers really helps with the explanation here. So we have our 22,000 physicians, and let's say that the experiment lasted for, say, 3 years. Okay, I never looked up how long it actually lasted, but let's just say it lasted for 3 years, all right? So let's say if nothing was done and they just lived their life normally, all right, within that time frame, we're going to say, we're just going to give it a number, that 2% of them would get a heart attack, all right? And that's if nothing was done, okay? Nobody took an aspirin, nobody took a placebo, they just lived their lives. 2% would get a heart attack, okay? All right, sound effects, look at that. All right, so now they join the experiment, okay? And roughly, what's going to happen is that if this all randomization happens, that roughly 11,000 will be in the aspirin group, and 11,000 will be in the placebo group. Now the important thing is that you need to pay attention to what I put here, is that before the subjects get the aspirin, okay? So we went ahead and took our 22,000, broke them up into two groups, roughly 11,000 here, 11,000 here. And this is before the subjects get the aspirin. That still 2% would get a heart attack. If they didn't take the aspirin, okay? So if they were just separated into two groups, okay? Let's say they were separated here, and then they said, oh, okay, we don't have the money to run the experiment, okay? What are they still trying to achieve, okay, by the randomization? That if we track these people over the next 3 years, that 2% would get a heart attack over here, and in the placebo group, remember this is before the subjects get the placebo, that 2% would get a heart attack over here. That's what we're trying to achieve by the randomization, okay? What we're trying to control are all the lurking variables. So let's think about this for a second. What are all the different factors that go into getting a heart attack? So let's see, poor diet, lack of exercise, stress, genetics, all those things that go into getting a heart attack. Those are all lurking variables. We're not measuring them. We know that they're there, okay, but we're not measuring them, all right? But we know that they're there. And so what we're doing by the randomization is that when you mix up people randomly, okay, and let's face it, doctors are, they're overweight. They can be overweight and have a poor diet and lack of exercise, plenty of stress. They can have poor genetics in their family, so on and so forth, right? So all those things that go into getting a heart attack, we basically want to mix all those people up, okay, between these two groups. And by doing this randomly, all right, we have shown over and over and over and over and over again that mathematically, that with regards to the response variable, they will be basically separated to the point where you basically have then 2% over here and 2% over here, whatever it was, if the groups were back being combined together. Okay, so we want to still have 2% of this group over here to potentially get a heart attack, and 2% over here. All right, and that's if nothing was done. We just put them in groups. Okay, that's what we're trying to achieve with randomization. All right. So the researchers want the groups to be the same regarding heart attack, the response variable before they get the treatments. That's what we're trying to achieve. Okay? And we do this with randomization. All right? So like I said, the lurking variables are mixed up between the groups now. Okay? All right. So in other words, basically what's going to happen here is that we're not going to have one group that is now more prone to getting a heart attack than the other group. Everything's been mixed up substantially, and we can pretty much guarantee you mathematically that these two groups are going to look very, very similar to getting a heart attack at this point. Okay? If nothing else was done. Right? Now, what's going to happen though? We're going to run the experiment. Now we have them into two groups. Both have the same chances of getting a heart attack. There's still 2% within the groups. Okay? And now the treatments are administered, meaning, okay, now this group is going to get the aspirin, this group is going to get the placebo, all right? So if we basically had the same percentage of getting a heart attack over here as we do over here, but in the end, we have a difference between the two, okay? Now we have a difference between the two. What's causing it, okay? Well, let's see, the lurking variables are accounted for because of the randomization. So if there exists a significant difference in the percentage that got a heart attack, it's caused because of the difference in treatments. Okay? So there existed a significant difference. It's caused because of the difference in treatments. Okay? So remember I said that there was 44% less heart attacks over here than over here? Well, okay, so if the only difference now between these two groups were the treatments, aspirin versus placebo, and this group was significantly lower than this one, well, it must have been because of the difference between the two, and it must have been because of what? Because that group got the aspirin, and this one didn't. And so Bayer, the makers of Bayer aspirin, then can get on TV and say, you know what, an experiment was run, all right, and we found this, okay, and so now we can establish cause and effect now, okay. Now, just to also let you know this, is that with experiments should be able to be replicated. Somebody else, some other group should be able to come in and do roughly the same thing and come up with the same results. If it can't be replicated, okay, something funny may have happened at that point, okay? And so a lot of this stuff, a lot of the experiments are replicated by other groups to verify that, oh yeah, okay, I got the same results as Group A did, okay? And so when that happens and we get a different research group getting roughly the same answer, there you go, okay? It's verified now, okay? And so this is an important tool for researchers, okay? So if an experiment is conducted properly, the researcher or the researchers can establish cause and effect between the explanatory and the response variables. That's what's important about an experiment, okay? So this is kind of like if the researcher can do this, they want to run an experiment because it's like the gold standard, all right? This is what we want to do if we possibly can, okay? Why? Because it establishes cause and effect, all right? All right, let's talk about observational studies. With observational studies, what happens is that sometimes we run into scenarios that we just can't run an experiment, okay? We just can't do it. All right. So even though researchers may want to run an experiment, there are circumstances that won't allow it. One is money. Okay, costs a lot of money to run an experiment. Okay, and so you gotta. There might be experimental drugs. You might have to pay your subjects. You might have to pay for some facilities, so on and so forth. Okay, so it costs a lot of money. Takes time. You can't just do this in a month. This could take years, decades even, okay, depending on what you're trying to study. And then the one thing I want to focus in on is ethics, Okay, ethics has stopped us from doing experiments. Okay, and so I want to I think money and time are pretty obvious. Okay, let's focus in a little bit on ethics. All right. So I was driving in one day into work, and I was listening to the news. And by the way, every newscaster will make it sound like everything was done as an experiment. Okay, and you got to put a critical eye to when you hear these things. All right, and so I was driving in one day, and then the newscaster started talking about vasectomies and prostate cancer. That as men, as the chances of getting prostate cancer goes up if a man had a vasectomy. All right, and the newscaster made it sound like an experiment was run, and it actually made me laugh out loud when I heard this. So let's think about this for a second. By the way, let me just mention this. Maybe you've heard of a blind study, or maybe even a double-blind study. So a blind study is when the participants, the subjects, have no idea of which treatment they're going to get. Okay? A double-blind study is that even the researcher has no idea what treatment the subjects are going to get. And so nor do they know what they don't know what it is as they go through the experiment. The only way that they actually know is that everything was number coded, and at the end of the experiment, then they look it all up and say, oh, this person got the placebo, this person got the aspirin, okay, so on and so forth. All right. And so let's have some fun with this. Let's say that we ran this as a blind study. Okay. That means, now if you think about this, okay, what this would mean is that we would have to have men volunteer to have a vasectomy, and we can't tell them if they got a vasectomy or not. Okay, well, let's still have more fun with this, all right? So let's think about what we would have to do at this point. So maybe we have some crazies out there that say, okay, I'll do it, right? Okay, so fine. You bring them in, and you have the first guy there, okay? And so remember, we can't tell them if they had a vasectomy or not, all right? So we'll put them on the operating table, okay? And, well, it's not going to be an operating table. It's probably going to be in a chair. And you go ahead and give them some local anesthetic. That's first thing, right? Got to numb everything. And then you're going to cover things up so they can't see what you're doing, okay? And remember, we can't tell them if they had a vasectomy or not, okay? So you got to either give them a vasectomy or pretend to give them a vasectomy. Okay, this is getting interesting now. So what are you going to have to do? Okay, so you're going to have to, as a researcher then, so everything's covered up, give them the local anesthetic, and you're going to make 2 slits. And you can imagine where those 2 slits are going to happen, okay? And because you're going to have to pretend that they had a vasectomy or not, right? And so if you're pretending, you're still going to have to, what you're going to have to do, you're going to have to go ahead and make 2 slits, right? And then either you're going to actually cut the Vans deferens tubes or pretend to, all right? And then sew them back up and then send them on their way. What do you think? Does that sound ethical to you? Doesn't sound ethical to me. So let's see. We just went ahead and made 2 cuts into a male, and now they can get an infection from it. They don't know if they can have kids or not, so on and so forth, right? Highly unethical stuff, right? And so, so ethics sometimes stops us from doing these things, okay? And so, with observational studies, we can't do any randomization, okay? So what happened here is that we can't randomly pick if a guy is going to get a vasectomy or not, okay? So right there, it kills an experiment, okay? So with an observational study, researchers do not do any type of randomization, all right? We allow the subjects to make their own decisions. So do guys make their decision about having a vasectomy or not? Yes, of course. Okay, they're the ones that are making the decision. We allow them to make the decision for themselves. Okay, and then we simply observe the response variable. Okay, we kind of sit back and say, okay, well, these guys volunteered to have a vasectomy, these guys didn't. And then, oh, look at this. Well, over here, looks like prostate cancer is higher for the vasectomy group than the non-vasectomy group. And that's all we can do at that point. And so, because there's no randomization, we cannot assume that the lurking variables have been spread evenly between the groups. Okay? There's no randomization. Remember, the one group could go ahead and choose what, both groups can all the men can choose which group to be in, right? And so we cannot guarantee that the lurking variables are accounted for, all right? So now what could happen is that because of other circumstances, you might have males that have something else in common, all right, go into the vasectomy group, all right, and they get the prostate cancer because of that other thing that they have in common, all right, and so which would be the lurking variable here, all right. So we cannot account for the lurking variables, all right, and so with observational studies, we cannot establish cause and effect. So experiments, because of the randomization, we can establish cause and effect. However, with observational studies, because we had no randomization, the lurking variables can have an influence. All right, cause and effect cannot be established with observational studies. Okay, and so by the way, ethics hasn't always stopped us from running experiments. All right. This might be surprising to some of you, but here's an example, is polio vaccination experiment. And so I'm actually recording this while the whole coronavirus pandemic is going on, all right? And so they're trying to come up with probably a vaccination right now, right at this time that I'm making this video, for the coronavirus. All right. Well, back in, I think it was about early 1950s. Okay, polio was a pretty big problem in the United States. All right, and actually we had a president who had polio, FDR. All right, and so polio would stricken a lot of times young kids, and also it would stricken older people. Okay, and so it was a pretty big problem across the world. Okay, and everybody was looking for a way to stop these viruses, all right? And so Jonas Salk came up with the idea of, hey, let's take this virus and weaken it to the point where it can't really harm anybody, but we're going to go ahead and inject it into somebody and let the body create antibodies based upon the weakened virus. And so if the person does come in contact with the virus, the person can fight it off, all right, because they have the antibodies, all right, thus the vaccination, all right. So why do I bring it up here? Well, believe it or not, that what happened was that they went ahead and tested. You want to guess who they tested? They tested first, second, and third graders. They tested millions of kids. Well, I shouldn't say millions. I think it was it was over 1 million kids. Okay, and parents signed all right off on it and said, "Boy, this is such a problem. We'll go ahead and test my kid." And so they had no idea. Now remember, this idea of a vaccination just started. Okay, and they didn't know if it was going to work. And so they didn't know if just by weakening the virus that going to be enough to allow the body to create the antibodies, or was the person still going to get polio? All right, and we had all these kids given the vaccination, not knowing if it was going to work or not. And so if you want to take a look at this, you can click on, maybe copy this that link right there. It'll take you to the History Channel, and it'll give you some details. And actually, believe it or not, they didn't even run the experiment correctly if you look at it closely enough. So, anyways, but so we have stopped such things, okay, and we would never do that today, all right? So we didn't always stop it, with that ethics, all right. All right, let's move on. So now we could take a sample instead of conducting an experiment or run an observational study, okay? And so we could either take a sample, so we're talking about sample stuff, either we could take it non-randomly or randomly. I'll talk about the randomly in a second. So the non-random sample, an example of this would be a convenience sample. So what's a convenience sample? Well, let me ask you this. If I told you to go ahead and whatever university you're at right now, if it's the University of Akron or if you're taking this remotely from another university, if I told you go ahead and gather some information from 30 of your fellow students, who would you immediately probably turn to? Okay. Now, some of you might go ahead and try to do this as randomly as possible, but I would bet there's a large group of you that would go straight to what? Your friends or the people that you live with or people that are in your dorms and stuff like that. Well, that's a convenience sample. It was easy to go find people, easy to go find things to go ahead and sample, okay? Now, so I'll give you another example of the convenience sample. Pretty much any internet sample would probably be considered a convenience sample. Now, I know there are some situations where you could probably take a sample and get a fairly good one from the internet, but for the most part, an internet sample would be considered a convenience sample. So, why would that be? Well, why do people go to certain sites? They go to certain sites because they have an interest in looking at that data, okay? And so that means everybody who has an interest looking at that data is probably going to go to that site. And all of a sudden, boom, it's created a problem now, okay? Because all those people have something in common. It's not really random, okay? So for instance, if the Republicans made a site, who's generally going to go out to the Republican website? Republicans. And same with the Democrats, okay? And so you got to be careful in creating a sample based upon internet information. Okay. We could also take a random sample, and the reason why we take a random sample is that we try to avoid what's called bias. And I'll give you a very broad definition of bias. As you get into more stats courses, you will see that it takes even a deeper meaning and definition. All right, but when we think about personal bias, okay, it's our own, we're sort of influenced by our way of thinking. All right, and so what we're trying to avoid as best as we possibly can when we do random samples is that we're trying to avoid bias. All right, and there are different, there's different types of random samples that we could do. We can take a simple random sample, which a lot of times is just designated as an SRS. 2, we can take a stratified random sample. 3, we could take a cluster sample. That's also random. All right, or we can do what's called a systematic sample. All right, and so all of these we could go ahead and do, and they're all random in some way, shape, or form. Okay. And they have their own aspects and good and bad points to them, and so on and so forth. So let's go through these. Okay. Oh, by the way, before I leave this slide, we'd rather have a small random sample, okay, versus a large non-random bias sample. All right. So if we could take a random sample, and it was only of say 70 people, versus a non-random sample that was biased, I could care how large it was. Okay, I could care how large it was. I do not want the biased sample. All right, So there's a classic example. There was a magazine that, believe it or not, this has to do with FDR again. FDR was running against a guy, I think his name was Landon or Langdon or something like that. And so FDR was the Democrat, and Landon was the Republican. And what was going on at the time was the Great Depression. Okay, and so during the Great Depression, we needed to pull the United States out of the Great Depression, and for that matter, the world. And so the Democrat FDR, he thought the best way of doing that was to tax heavily the more wealthy people. All right, and so to go ahead and give more spending power then to the middle class and the lower class by bringing in more taxes, and then that the government could put to work more people and achieve that. Okay, and so what happened was that there was a magazine that wanted to try to predict the outcome of the presidential election. And so the magazine went ahead and put one of these things where you could rip out of the magazine and you could just simply check, hey, this is the person I'm voting for, and drop it into the mail. Okay. And what also they did is that they got a hold of anybody who had a car, all right, and anybody who had a telephone. Now we're talking pretty far back, okay. And so, that sounds silly to us today, okay? But, way back when FDR was president, not too many people, not a tremendous amount of people, I should say, had a car, nor did they have a telephone, nor did they have enough money to own a magazine, okay? And so, back then, basically, if you're going to contact people that just had a telephone, who could afford a magazine, who had a car, who were you contacting then? You were basically contacting anybody who had a fair amount of money, okay? And who, generally speaking, who were those people going to vote for? They were going to vote for the Republican at that time, okay? And so what happened was that the magazine went ahead and published this, and the magazine got, I think, something like 3.1 million people to tell them how they were going to vote. And they published in their magazine that FDR was going to lose in a landslide. And you would think that with that many people that are giving their opinion, that would be good enough. But it's not, because it wasn't even close. It wasn't even close. Their results said that Landon was going to get 2/3 of the vote, and FDR was only going to get a third, and FDR was going to lose in a landslide. And it was the exact opposite. Okay, exact opposite. So I don't care how large of a bias sample that you have. I don't want it. Okay. By the way, that magazine went out of business very quickly after that. All right, and so lessons to be learned from the past. Okay, so let's talk about a simple random sample. So what is a simple random sample? Every sample of the same size has exactly the same chance of being selected as a sample to represent the population. Okay, so just sort of imagine this in class. Okay, you're in class, and I go ahead and say, all right, out of this group of students, maybe we have 40 students in class, and I say, think of any 10 people in this classroom right now, okay? And then think of any other combination of 10 people, okay? Well, there's a lot of 10 combinations there, okay? There's a lot of combinations of 10 people there, all right? But no matter how many there are, all right, each one has exactly the same chance of being selected to represent the population. And that would be a simple random sample, all right? That means you need to get a list of the entire population, all right? Okay, so no matter how big the population is, you're going to need a whole list of them, okay? And then you're going to have to randomly pick, Okay, and a lot of times you randomly you put this stuff in a computer and you randomly pick at that point, because the computer's not going to have any bias. Okay, and so that's usually, I'm not saying that's the only way of conducting a simple random sample, but usually that's what happens. Okay, so this is the gold standard for random samples. Okay, so if we could achieve this, great. Okay, let's go ahead and do a simple random sample. The problem is that it's very hard to accomplish, and the reason why is the thing that makes it great makes it hard. Okay, why? Because you need a list of the entire population at that point. Okay, and that's hard to do. That's really hard to do, especially if your population is millions and millions and millions of people or things. Okay, and so we've come up with other methods other than a simple random sample. Okay. Because sometimes we just can't achieve a simple random sample. And then we might have circumstances that we might want to just go ahead and use a different way of going about things. So we have this idea of a stratified sample. So what happens with the stratified sample is that the researcher purposely takes the population, divides it into groups called strata. Okay, and so why do we want to do this? Okay, there's got to be a purpose. When you do a stratified, you are purposely, you're saying, boy, I want to separate the population into these groups on purpose. Okay, so we don't want one group to possibly dominate the sample or be underrepresented. Okay, and you can think of just about every political poll as a stratified sample. So, for instance, let's say that here's our population. Okay, we could go ahead and take a simple random sample from there. But what could happen with a simple random sample is that the sample might get dominated by Republicans or Democrats, or for that matter, independents. And we don't want that. Okay, in the United States, we have a pretty good idea how people think with regards to political opinion, and who's what percentage are Democrats, what percentage are Republicans, and what percentage are independents. Okay, so when we take a random sample, okay, we would want roughly the same percentages. Okay, and so what we do is that we take our population and we start dividing it, I should say, into these different groups. And so you might have the Democrats here, Republicans here, independents here. And believe it or not, you do not need a list of the entire population at this point. Okay, and the reason why is because you could go ahead and say, okay, today, because of how the United States is broken up in with regards to how people think with regards to being a Democrat, or Republican, or independent, we would want maybe 40% Democrats, 40% Republicans, and 20% independents, or maybe we would say 45, 45, and 10, whatever. Okay. So when you go ahead and there's these computer programs that will just randomly call numbers, right? And once a person answers, then the person who is doing the surveying will ask, ma'am, sir, are you a Republican, Democrat, Independent? And then, so you do not have to have an entire list of the entire population. All right? You can just ask them which party you belong to. Okay? And when you go ahead and do your random sampling, then that means you just want to make sure that you have enough Democrats, Republicans, and Independents that it seems very reasonable to represent the population. By the way, when we do those, we don't ask millions and millions of people those political polls. So when you see those political polls come out, maybe 2 months before the election, actually we're having a presidential election this year in 2020. All right, so a few months before the election, you're going to start seeing these political polls, right? Who's going to vote for Trump? Who's going to vote for? Actually, Bernie Sanders just left. Okay. So Joe Biden is going to be the Democrat, and I don't know if there's going to be a major independent in there. I doubt it. Okay, but whatever the case may be, we only ask about 1,000 people. Okay, we don't ask millions of people. Those political polls, those made by the different news organizations, only ask about 1,000 people. Okay, so let's go back to the stratified example. So now we have our different groups here, and what's going to happen is that we're going to go ahead and basically take a random sample from this group. We're going to take a random sample from this group. We're going to take a random sample from this group, okay, until we can achieve the correct sample size. All right, so there's a stratified sample. All right. Okay, cluster sample. Cluster sample. What happens with the cluster sample is that actually, let me give you an example of what happened in the way in the past. Pretend these are city blocks. Okay, these are city blocks, and so there's a whole bunch of them. And let's say we have a very large city. Okay, and the people who run the city want to take a sample of the adults in the city. Okay, so on and so forth, and so we got a whole bunch of these city blocks. And so what used to happen is that if you're going to take a simple random sample, they would choose people randomly, and then they would have to physically go around to these different places. So they might go here, okay, and go find this person here in this city block, and then they would have to go here, and then they would have to go here, and then they would have to go maybe find 5 people here, and then 7 people here, and then 2 people here, and then maybe no over here, and then maybe 6 people over here, okay. And so it was very inefficient, okay, very inefficient. And so what they decided to do was do this cluster sampling, okay. And so with the cluster sampling, what was going on is that these city blocks then would be the clusters, okay. So the city blocks would be the clusters, all right. So city blocks. Oh boy. So the city blocks would be the clusters in this situation. Oh my goodness gracious, look at that. All right, looks like a second grader or a 2-year-old wrote that. So our city blocks are the clusters, okay? And what would happen is that we would go ahead and number these. 1, 2, 3, so on and so forth, okay? And then we would randomly pick clusters, okay? So we would randomly pick clusters, and then everybody in the chosen clusters would get sampled, okay? And so if cluster 2 was randomly picked, everybody in cluster 2 would be chosen to be in the sample. And if cluster number 5 was chosen, everybody, that's what makes the difference between this and stratified, is that everybody in the chosen clusters would be sampled, okay? And so cluster sampling, okay, we sample all the people or things in the chosen clusters. So with systematic sampling, what's going on is that a lot of times this is done in manufacturing. And so with systematic, maybe I can give you an example like with Hershey Kisses. And so what's going on is that the manufacturer wants to sample Hershey Kisses as they come off the production line. And the reason why is because, you know, as a consumer of Hershey Kisses, what do we expect from a Hershey Kiss? You know, let's think about all the things that we expect. We expect it to taste a certain way. We expect it to, we expect it to be a certain size. Okay, we don't expect it to be really, really small or really, really large. Okay, you know, if we buy a bag of Hershey Kisses, we expect some fair amount of uniformity with regards to the size of them. We expect them to be individually wrapped in that wrapper with a little piece of paper coming out of the top of it, okay? And we expect a certain shape out of it, okay? And so Hershey has to make sure that when they make these and before they send them out, that that's going to be the case, okay? That the consumer gets what they expect. And so a lot of times a manufacturer will do systematic random sampling to sample their products off when they come off the production line. Okay. So now, what happens with a systematic random sample? Well, what would happen is that we would number the Hershey Kisses as they come off the production line, 1, 2, 3, 4. Okay. And what would happen is that we would start with a random number. That's where the randomness comes in. So maybe we start with that day Hershey Kiss number 4. Okay. And then depending on how many Hershey Kisses we make in a day, okay, maybe we'll go ahead and choose every 500th Hershey Kiss. Okay, and so what we would do is that we would sample the 4th Hershey Kiss, and then because we're going to go up 500, we're going to look at 504th Hershey Kiss. We're going to look at the 1004th Hershey Kiss. Okay, 1504th Hershey Kiss, and so on and so forth. All right, and so and what we want to do is we want to go ahead and conduct our tests on those Hershey Kisses, and we're going to quickly do that, and we're going to make sure then that our Hershey Kisses are up to production standards. Okay, and what else are we trying to do? What else we're going to try to do is we're going to try to figure out if we need to stop our production line, okay, and go ahead and calibrate our machine. So, for instance, maybe for the 4th Hershey Kiss, it was just fine. Okay, the 504th Hershey Kiss maybe was a little bit smaller than the 4th one, but nobody's going to notice anything. And then the 1004th. It was a little bit smaller. It was still within tolerance range, and so we don't have to go ahead and basically stop production and redo those Hershey Kisses. We're fine, but we realize that there's a trend going on here. Okay, we're trying to pick up on trends with regards to when we should stop our machines, recalibrate, so we don't have a bunch of waste. Okay, and so that's what's going on with a systematic random sample. All right, so that takes us to the end of chapter 4. Thank you for your time.